Dear students, I welcome you for the today's lecture where we are going to discuss related to the agitators. Its functioning, its designing parameters we are going to discuss today. So let us start one by one. We know already the different kinds of industrial mixing exists. That is the mechanical mixers, then the static mixers, rotating tank mixers, then the agitators. Now, if you will look at these static mixers, they are fitted into the pipes. That means the small section in the pipe is provided with a certain metallic structure so that that metallic structure or inside the design of that static mixer will provide the turbulence. So there is no movement of that metallic component itself, नो मूवमेंट ऑफ अ मेटेलिक कंपोनेंट जो अंदर में अरेंजमेंट है उसकी मूवमेंट नहीं हो रही है, उस डायरेक्शन को एक्सेप्ट कर रही है फ्लूइड फ्लो की मूवमेंट. दैट मीन्स if this is the pipe that is provided and I have provided a certain movement so that the fluid that will be moving or taking its path, and fluid will move like this by changing its direction so that the mixing will take place properly. Here there is no movement related to the mechanical part, but the mixing is taking place. Then rotating the tank mixers, that is another. We have already seen this on the roadside or construction sites where the tank itself that is rotated to obtain a proper mixture of your concrete. But in case of the agitators, a impeller and a shaft that is attached to a motor, this is related to the difference between the mixer and the agitator. We are focusing today related to that. Mixers, they doesn't move itself, mechanical part is not moving, but in case of agitators we are providing the circulatory motion to the fluid. Then the agitators that can be paddled, then by pump blasting liquids, then uh, turning tanks into the gas. Then there are, if you think of the agitator, then different phases that will come, that is liquid only, or liquid solid, or liquid and gas, or liquid or with the solids and gas. The three phases depending on different permutation and combinations of the different phases, that is gas, liquid and solid. Then depending on the type of the phase and the viscosity, bulk viscosity, the agitators can be different types of agitators that can be used, and they are named as certain mixers, kneaders, dove mixers. So these are the different names that is provided, but the purpose is to mix, purpose is to mix, to get a uniform concentration or a random concentration. The agitators used in liquids can be placed on the top of a tank on the vertical position or horizontally depending on the process requirement. Then this agitation that refers to the forcing fluid by mechanical means, certain mechanical means which is going to move actual physical movement that is observed for an rotating part that is related to the impellers and the shaft. And in case of a mixer, which implies taking of two or more separate phases such as the fluid and powdered solid or two fluids and causing them to be randomly distributed. एक में रैंडम डिस्ट्रीब्यूशन है, एक में सर्कुलेटरी मोशन प्रोवाइड की जा रही है. दैट इज अ डिफरेंस, बट द पर्पस इज दैट ऑफ अ मिक्सिंग. एक में रैंडम मिक्सिंग कॉन्सेंट्रेशन इज अचीव्ड एंड एजिटेशन में यू रिक्वायर द यूनिफॉर्म कॉन्सेंट्रेशन. Agitation is a means whereby mixing of the phases can be accomplished and by which the mass transfer, heat transfer and your chemical kinetics that increases between the phases or with the external surfaces. That is the purpose of mixing is concerned with all combination of the phases, of which the most frequently occurring one are the different phases, and where each gas and gases, they are mixed gases into the liquid. If they are mixed, that is called a dispersion. The gases with the granular solid that is mixed, it is called a fluidization or pneumatic conveying or sometimes drying. That is different purposes are there. Then liquid into the gaseous, that is the spraying and atomization. Then the liquids with the liquid, that is your dissolution, emulsification or dispersion. Then liquid with the granular solids, that is your suspension. Then paste with the each other and with the solids. Then with the solids, that is mixing of the different powders. Then agitation is a process in which the fluid is forced by mechanical means to develop the flow in a circulatory or other pattern inside the vessel. A definite pattern should be developed inside the vessel whereby the mixing of the phases can be accomplished and by which the mass and heat transfer can enhance between the phases or with the external surfaces. This agitation implies the forcing a fluid by mechanical means. Yes, the liquids are agitated for the purpose depending on the objectives of the processing step. So why do we agitate the liquid basically? What is the purpose? Is to homogenize with respect to temperature, component and the concentration, homogenization or a uniform concentration, that is the purpose. Then we are going to mix the liquids with the gases, with the solid particles, with the miscible liquids or with the immiscible liquids, and that finally helps for heat transfer and mass transfer associated with that. The method of mixing, that is by mechanical mixing, may be the rotating or vibrating vibrations, that also helps for mixing. Then hydraulic mixing processes, the fluid itself is rotated again and again. The pneumatic mixing, that is also there. Then pipeline mixing, that is the turbulent flow or static mixers that will be there. So mixing refers to any operation used to change a non-uniform system into the uniform one. A very non-uniformity is there initially and you require some degree of uniformity. That is the basic purpose of a mixing. The random distribution of two or more initially separate phases. It's a random distribution. It's not a uniform distribution which is expected in case of a mixing. The mixing usually implies the taking of the two or more separate phases such as the fluids or powders or the two fluids and causing to be randomly distributed through one another. Then the it's simply a physical process. Aim is that physical process, no aim of your chemical reaction that will take place. Chemical properties will not are not expected to change in this mixing process. But in case of agitation, it is expected that your chemical properties also may change. Then reducing the non-uniformities in the fluid by eliminating the gradients of concentration, temperature, and other properties. Then mixing, it's a random distribution. Okay. Now looking at these figures, these are all mixing with the help of pneumatic mixing processes, hydraulic or mechanical mixing processes. So first is a mechanical mixing using the turbines. It's the turbines, they are provided and they are rotated with the help of the agitator. So mechanical mixing using the turbines, that is there. Then B, mechanical mixing with the impellers, that is provided. So these are my two impellers, they are provided. I can provide the turbines here in this case. Then third is the hydraulic mixing. So water or the fluid which is available, that is sent back into the tank again, so that the fluid itself helps, the high velocity fluid itself helps for mixing process, that is the hydraulic mixing. The next is pneumatic mixing. So in this pneumatic mixing, I am going to supply the air. That is what the basic difference pneumatic and hydraulic. I am going to supply the air in case of pneumatic mixing processes with a stationary input. The next is a pneumatic mixing with automatic regeneration. Now this pneumatic mixing, that can be related with the solids or that can be related with the liquids, both the phases that can be there. So regulatory valves, they are provided at the bottom before the entry into the vessel. Next is a hydraulic mixing with the anti-foaming showers. Now, generally, if the two fluids they are mixed, the foam formation may take place because of the bubble formation. Foam formation can take place, and to avoid this foam formation, we are putting a certain mesh which is going to reduce the foam formation, and this fluid that will be again recirculated back, so that it is going to prevent the foam formation. Then this is the pipeline mixing. This is the third type, that is the pipeline mixing. Pipeline mixing can be turbulent flow or the static mixers. So this is the turbulent flow itself that helps. It is the general simple experiment, that is the certain dye that is injected into the fluid flowing through a certain small nozzle. As the flow velocity is low, it will gradually disperse and can increase the distribution slightly. But as we have slightly increased the fluid flow, then at an early stage you can observe the certain distribution. But if this velocity is drastically increased, then you can see that within a short span of the length of the pipe, it is completely dispersed. That means in a short span, it is completely dispersed. So complete distribution is there only because of the difference in the flow velocities at low velocity, at high velocity, and at very high velocities. The difference you can observe. This is related to the pipe mixing. Besides that, this fluid mixing itself, there can be certain static mixers are also that can be used. So what are agitators? That is the agitators are the machines used in industries for the mixing liquids together to promote the reaction of chemical substances, keep the homogeneous liquid bulk during the storage, and increase the heat transfer. That is the basic purpose of agitation generally, that is mixing liquids together, then keeping the homogenized liquid, that is for example in case of a suspension, that is the fluid should be in a suspension form, in a slurry form, that is other purpose is not there. One has to think of the simple purpose that is related to the mixing that will be there. The fluid should be homogeneous one, and the other purpose is that of a chemical reaction. We expect that a certain chemical reaction will take place, and finally it's a heat transfer, that is what is expected. Then agitation, that is it's a action, and mixing is putting them into the agitation, it's a action and putting into the motion by shaking or stirring. Generally it's a stirring that is preferred in case of a agitation, often to achieve the mixing. What is achieved in the process of agitation? It's a mixing that is achieved. Then this technique is mostly involves the agitation by stirring. So stirrers they are used. Stirrers, that is nothing but a spoon which is used in our day-to-day life for the purpose of agitation. And sometimes in industrial scale it is the shaft and the impeller which is used for the purpose of stirring. So agitators involves the stirrers. Then the agitation is achieved by generating the movement of the fluid or the liquid phases with the help of the impeller. So this is due to the mechanical agitators to a rotation of an impeller. Then the bulk can be composed of different substances, and the aim of the operation is to blend it or to improve the efficiency of reaction by better contact between the reactive products. Or the bulk is already blended, and the aim of agitation is to increase the heat transfer or to maintain particles in a suspension to avoid the deposits which is needed in case of a slurry. Then the agitation of liquid is made by one of the several agitation impellers. The moving of the liquid which is characterized by its velocity and direction. What is the depending on its shape, the impellers can generate the movement of the fluid that is to be moved, and that depends on its density, viscosity, the attached baffles, that is going to create a turbulence. Turbulence should be the erratic variation in the space and time of local fluid velocities. For that one has to understand the local velocity of the fluid. Local means the point velocity of the fluid at every point inside the vessel. If you will look the vessel uh, to be of a bigger size, then what will be the velocity of the fluid particles at this point? If I draw this as a vector, and if the fluid particle is here, its velocity can be the different. So fluid particle at this location and at this location will have the different velocities. So where is the turbulence that is created? More velocity, the more will be the turbulence. So the particles which are near to the impeller will have the higher turbulence, higher velocities, and that is what we call them as the Local fluid velocity. The fluid velocity at this particular point is the local velocity. Similarly, in case of a pipes also, the we take or we consider the average velocity, but if the fluid which is just around the pipe wall will have the zero velocity, surface पे जो है, that is a zero velocity we are taking it. So this is the local velocity at the different points inside the vessel is going to vary, and that is why we have already studied this related to the flow patterns that is developed into the pipe. And this is very much essential, that is the fluid mechanics, understanding of fluid mechanics in the creation of the turbulence. And this whenever there is a high turbulence, it is also going to have the high shearing between the two molecules. So this shearing, that is also going to create the velocity gradient. So turbulence and the shearing actions both are the power consuming. So it requires the high amount of the power consumption. But on one side, for better mixing, you require to be a good turbulent condition. Good shearing should be there. But it is on other hand, it is going to consume the higher energy. So one has to optimize for the best performance or best distribution or best uniform concentration between the amount of energy consumed due to the turbulence and shearing action. Does my amount of energy is consumed or wastage in turbulence or shearing, so that is going to increase the fluid temperature, that is going to increase the fluid temperature when I am going to consume the energy. So extra energy should not be consumed on this turbulence or shearing, but the basic purpose of distribution or attaining the uniform concentration, that should be solved. So there is a optimization that has to be done, so that energy should not be wasted in turbulence and shearing actions. Energy should be properly utilized only for the purpose of achieving the uniform concentration. कंसंट्रेशन यूनिफॉर्म करने के लिए मेरी एनर्जी यूज होनी चाहिए, ना कि वो टर्बुलेंस और शेयरिंग में वेस्ट होनी चाहिए. सो उतना ही टर्बुलेंस क्रिएट करने का है which will be helpful for achieving the uniform concentration. Excess turbulence will lead to the loss of energy, loss of power consumption. So propellers gives an inlet and outlet which are on the axial direction, preferably downward direction. They are characterized by nice pumping flow, low energy consumption and low shear magnitude, as well as the low turbulence. Now what are these impellers? Impellers, these propellers, they provide the axial direction. Axial direction, that is corresponding to the vertically alignment, generally to in the axis. So whenever there is the axis, I am going to have the axial stresses, that is corresponding to the parallel to the axis of the vessel. So it is the axial direction, then preferred into the downward direction. These are your propellers. So the fluid that will move into the axial in the downward direction, and there are a nice pumping. The fluid that will be pumped in the downward direction with a low energy consumption, low shear. That means the turbulence pumping is there, but low shearing is there. So the magnitude of low turbulence, low shearing is there. In case of turbine impellers with an inlet flow, that is the axial, and the outlet flow is a radial. So both the directions they are developed into in case of a turbine impellers, that is in a radial direction as well as in a axial direction. This is the axial direction and this is the radial direction towards the radius, and towards the axis it's a axial direction, towards the radius it's a radial direction. So and it should have the low shear and low turbulence. That should be the purpose while agitation. Now coming to the different mechanical features of the agitators, that is the agitator which is provided into the vessel for the purpose of the mixing. So this is my agitator. You can see here the agitator, the complete assembly of a agitator, which is incorporating a drive motor, the speed reduction box, because the motor which is having the fixed RPM, what is the speed required, what is the RPM of the shaft required, that may not match with the motor RPM. So the desired degree of speed reduction or is provided by this gear reduction box, and then the mechanical seal which is going to prevent the vapor losses from, or the liquid vapors which are generated inside this tank will be prevented by going outwards. So that is the purpose of a mechanical seal. Then the shaft that will be there and the impeller blades that will be provided. So this is the complete assembly of an agitator that will be there. So an agitator is composed of a uh, drive device, that is the prime mover, that is nothing but your motor, then gear reducer or the belts, coupling or transmissions, a guiding system of a shaft, then seal, support, as you have drawn in case of your uh, drawing, the support and mountings are there, a shaft and an impeller. An agitation system consists of one or more impellers also, not necessarily always only a single impeller. It can be the multiple impellers. If the operating conditions are under high pressure or high temperature, the agitator must be equipped with a mechanical seal system to keep the tighten the inside of the tank when the shaft is crossing it. If the shaft is longer, then there can be the certain bearings at the other end that can be also provided. Then now coming to the various parameters of the basic equipment useful for agitation system design. That is the ratio of designing parameters which are to be looked. So the ratio of liquid depth to the vessel diameter, that is nothing but your L by D ratio, and generally the L by D ratio is equal to the 1, generally preferred for stir tank reactors or where the reactions are taking place. It can also be between zero point 0.5 to 1.5, that depends on again the process requirement, but generally L by D, which is equal to the 1 or unity ratio, is most advisable. Then liquid depth, it indicates the cylindrical height of, in case of a flat bottom vessel, in case of a flat bottom vessel. If the vessel is a flat bottom, then its liquid cylindrical height that will be taken into consideration. The flat bottom that will be there. So this is the liquid height. You can understand it. If the vessel has a dish bottom, now I'm providing a dish bottom, a certain head that will be provided, and which is the most common in case of our chemical industries. So if the vessel, the dish bottom, then the distance up to the center of the dish is considered as the liquid depth. So I have to take the liquid depth from the center of the dished head. Then if the coils are provided in the vessel for heating or cooling purpose, then their pitch should not be closed one. Now the coils which should be provided, they will be around the shaft, but the shaft and the impeller should not touch these coils. Shaft and the impeller should not touch the coils. So that is sufficient spacing that should be provided between the shaft or the impeller and the coils. Then the baffles, they are also provided for better mixing and to promote the turbulence. So this should be welded to the vessel. The vessel wall in case of low viscosity liquids. That is generally if the viscosities are low, then we are providing the baffles and some clearance that is maintained within the vessel wall and the high viscosity liquids. So if it is the vessel that is provided and if it's a baffle that is there, some clearance that will be provided so that the liquid will be able to move between this gap. Liquid can easily move between this gap so that the dead spots will be avoided. Dead spots will be avoided. Now if it is the vessel wall, if it's a vessel wall and if it is attached to this site. So on this site, the dead spots will be developed. The fluid will not move in this case, and for that purpose, these baffles, they are attached to a certain distance, so that the fluid will be very easily passed and dead spots will not be developed. So this vessel wall in the case of low viscosity liquids and some clearance should be maintained with the vessel wall in case of high viscosity liquids. So other fittings which are necessary in case of your reaction vessel, that is the deep pipes, thermo wells, then the draft tubes. So these are the different fittings which will be available into the vessel. Deep pipes, that is the purpose for measuring the height. Nowadays, instead of providing the liquid gauges, the liquid deep pipes, they are provided for the measurement of the liquid height into the vessel. That means the nitrogen that is passed through this liquid pipe and a certain back pressure will be developed due to the liquid height into the tank, and this back pressure that is measured here, that is your differential pressure measurement system, which will be measuring the liquid height into the tank. Then thermowells, that is for the purpose of measurement of a temperature. Then the draft tubes that helps for increasing the turbulence, where the fluid movement that will be observed through the draft tube. Then other the energy requirement, that is one of the most important aspect that is to be studied in case of our agitation system. Power consumption, whether my energy is getting wasted in turbulence and shearing, or is it only utilized for the purpose of mixing. यहाँ पे मेरे को डिस्टिंक्शन करने का है, समझने का है, and that is what the understanding of a chemical engineer is there, whether my energy is wasted or whether my energy is properly utilized. Am I providing the extra energy which is wasted in turbulence and shearing? So the process has to be well defined. Now, any process of agitation process, whenever there is a stirring that is taking place, a uniform flow patterns that will be developed, and this flow pattern should be well defined. Then and only then we can reproduce the same quality material. If these are non-defined or very chaotic or very turbulent conditions, then every time there is a possibility that you may end up with a different quality. So you require the well-defined systems. So turbulence, whatever we are creating, the required turbulence, whatever we are creating, we are creating the rotary motion, that should be well defined. So mixing systems is to be designed to make up and hold in the uniform suspension. For example, a 15% slurry that may require the different amount of the energy. Then description of the components, that their final properties at the initial stage, final stage, that is going to vary. Then the details of the tank geometry, that is also very much essential. And the what are the L by D ratios, that is also needed. The outline of a mixing cycle, it depends upon the nature of operation and decide whether the process is a batch operation, semi batch, or continuous one. That means depending on the type of the operation, this mixing cycles that is going to vary. It is not always necessary that you will have the continuous processes. In case of batch or semi-batch processes, your initial mixing of agitation, initial mixing processes, that matters a lot. And that is why some people say that it is the art than science also sometimes, and that is what it's here uh, at initial stages, how much amount of the mixing and with what rate that mixing has been carried out, that is matter a lot. And this is also applied to our day-to-day home recipes also, how much mixing that is going to create, and which is going to help for creating the different tastes. Now if we will look at this figure, what will be the liquid height inside this tank. Liquid height minimum should be maintained to the L by D ratio, which is equal to the 1 generally, and it can vary from zero point 0.5 to 1.5 depending on that. Now, why I'm going to provide this extra space above this liquid height? So that the liquid that will be which is getting vaporized, so to accommodate the vapors, I am providing this head space. It is called the head space. So it's a vacuum volume or the liquid. Up to this height the liquid will be there, but above that the vapors will be there. Now it how much amount of the head space that should be provided, that depends on the temperature. So whatever the temperature of the working fluid that is there, if it is near to its boiling point, that means more vapors will be generated. If the liquid operating temperature is around its boiling point, that means more vapors will be generated. So if as the more vapors are generated, I have to provide the space so that the vapor head space will be there. Now there are also the seals, they are also provided, mechanical seals. Now sometimes or operation wise, whenever the head space is less or certain high pressure that is developed here, it is a possibility that you may end up with the leakages from vapor leakages from here, from the mechanical seal. So you may end up with the vapors. That depends on the pressure in the head space. Pressure of the vapors in the head space may end up with the leakages, frequent leakages if there are. Then one has to think of the head space and how much amount of the height liquid height that is going to vary. Sometimes the leakages inside the around the shaft. Then the agitation equipment, that is the purpose, various types of the vessels and tanks of different geometries and shapes and sizes are used in the mixing fluid. Then the top of the vessel may be the open or sealed. The vessel bottom is normally not the flat but rounded with provided with the certain heads to have the uniform stress distribution. Eliminate the sharp corners and regions into which the fluid currents will not penetrate. That means the fluid will not have the dead spots. The uniform fluid distribution will be there. Uniform velocities, local velocities should be uniform. Then the depth is approximately equal to the diameter of the tank. An impeller is mounted on an overhang shaft. Overhang shaft, the impeller that is mounted on this overhang shaft. The shaft is provided with motor, and this is sometimes directly connected to the shaft but is more often connected through the speed reduction or the gearbox. The other attachment that includes the inlet, outlet, coils or jackets, as well as the thermo wells. These are the other different equipments. Now looking at this figure, generally it's a standard configuration, you can say, related to the vessels. So it's a diameter dt, that is the diameter of tank. H is the vessel height, liquid height inside the vessel. The baffle width, that is the J, defined as the J. Then E is a distance, height of the agitator from the bottom of the tank. Then dA, that is the agitator diameter of the agitator, or you can say diameter of an impeller, specifically talking, diameter of an impeller. W is the width of an impeller blade, L is the length of the impeller blades. So these are the specifications and that will have a certain correlation. Now it's a tank diameter dt, which is most important thing. Dt is the tank diameter and they are all related with that. So it's dt and the dA. That is the ratio of dA and dt, which is taken as one third generally. Then height h by dt, that is nothing but L by dt, tank diameter, that is taken as the 1. Then J is nothing but your baffle width. Baffle width to the tank diameter, which is 1/12, which is 1/12. Baffle width to the tank diameter, that is 1/12. Then E upon dA. E is your height of the agitator from the bottom of the tank, and dA is the diameter of the impeller. That is, they are equal. E upon dA, that is almost equals to 1. Then L by dA, then W by dA, this is 1/5. W is the height of the impeller blade, and L is the width of the impeller blades, length and the height, you can say, or the width. So they are having all the correlations which are used for general configuration. It's a standard general configuration, but again it depends on the type of a impeller. If it's a propeller type or a paddle type, then these configurations are okay. Now, if it is an anchor type, then the another different type of the configuration has to be taken into consideration. So it's the most important which type of the impeller we are using, and which type of these configurations or the geometric proportions has to be taken into consideration related to the stored tank vessels. So agitation plays an essential role in the success of many chemical processes, and there is a wide range of commercially available impellers that can provide the optimum degree of agitation for any processes. A lot of agitator or impeller manufacturers are there, and your chemical processes, which is an art also, and there it requires the understanding of the agitation, fluid mechanics, all your chemical engineering basics, they are required. The problem arises in selecting the best impeller for the required process. That is what the experience, the person's experience talks related to all these select